Hello mathematicians, puzzlers, and other curious people. In this video, we are going to help Frank set a limit. So Frank is a 21-year-old, 175-pound college student, and he's going to a party. And there's going to be drinking at this party. Now mind you, I'm not saying anybody should drink or shouldn't drink. That's not my place to say about anybody else. I'm just telling you what Frank decided to do. Frank does not have a designated driver. By the way, having a designated driver is a great way to go about things, but it's not what Frank did. There's a lot of things Frank doesn't want to have happen as a result of this party, though. He doesn't want to get a ticket, make his insurance expensive, lose his license, wreck his car, get injured himself, injure other people, or, and this is kind of a subset of getting injured himself, get a boot in his backside from his mother who is an ER doctor. So she's seen a few things. So Frank needs to set a limit for how many drinks he's going to consume. Now, fortunately, there's a formula for this, so we can use a little bit of math to help Frank out. Blood alcohol concentration, about an hour after drinking, approximately follows a certain formula. B is the blood alcohol concentration as a percent, and that follows the formula 600 times N, where N is the number of drinks the person has had, divided by W, where that's their weight in pounds, times 169 minus 0.6 times N, where N is still the number of drinks they had. If we need to figure this out based on Frank, we can get rid of one of these variables, and then we'll have a two-formula relationship. So we know Frank's weight from the problem statement. He is a 175-pound college student. So now we can do a little bit of plugging things in, and we can get this somewhat simplified version. We can simplify this a bit further. So we can distribute that 175, and this looks like an excellent calculator problem. 175 times 169 is 29,575, and then 175 times 0.6 is 105. We could actually keep simplifying this further. For one thing, I notice everything's a multiple of 5, so we could factor out a 5. But you know what? I think this version of the formula will be quite easy to use. So here we have a two-variable formula, where N is the number of drinks, and B is Frank's blood alcohol concentration 1 hour after finishing drinking those drinks. And we can think about numbers that make sense for this. It's possible that Frank could drink 0 drinks, so N could be 0. It's also possible that Frank could drink a positive number of drinks, so N could be greater than 0, possibly. I know it's not possible for Frank to drink a negative amount of drinks. There is no such thing as negative alcohol. So we know that N is not less than 0. Although it would be possible to drink, say, half a drink or 3/4 of a drink. For purposes of this problem, it's probably easier if we just round to the next whole drink up as soon as we start one. So I'm going to say in this case that for purposes of how we will calculate, N is a whole number. That's the N with a double back. That's the symbol for the natural numbers. So N is one of those numbers that you count with, 0, 1, 2, 3, etc. We can then make a chart of the possibilities of how many drinks Frank might drink. And we can calculate Frank's blood alcohol concentration as a result of drinking those drinks. If Frank drinks 0 drinks, this is actually really easy to calculate. We don't even need the calculator for this one, because 600 times 0 would be 0, and 0 over anything is 0. So Frank's blood alcohol concentration is 0 if he doesn't drink at all. Makes sense. But what if he drinks 1 drink? So we'd have 600 times 1, but that would be divided by 29,575 minus 105 times 1. And our result there would be about 0.02. Now again, that's already in percent, so that's not 2%, that's 0.02%. That's like if you take a percent. So if you take a percent and zoom in on it, then we're taking a percent of a percent. So a very small amount. So what happens if Frank has more than one drink? Well, let's say he has a second drink. Well, at that point, his blood alcohol concentration would be about 0.04%. By the way, this is showing some interesting things that would need to happen. So we know for a fact that his blood alcohol concentration will always, as a result of just physical possibility, be less than or equal to 100, because that's a percent. Furthermore, if Frank had 70% alcohol in his blood, he would be a cleaning product, which is not physically possible. So he certainly won't exceed that. And realistically, it would be a much lower amount that's even physically possible, or Frank would not survive. But we know 3 drinks is a possible amount that people do and survive all the time. And that would give him a blood alcohol concentration of about 0.06. Now, this looks like it's approximately linear. It is pretty close. Part of that is because we haven't gotten to values where it accelerates very much. If Frank drinks 4 drinks, now here's what I see. At that level, it would be a little more than 0.08. So Frank at this level is not legal to drive. And that limit is set because it's a more risky level, so the other consequences, like hurting himself, hurting someone else, or his mom putting a boot in his backside, would definitely be possible at that level. So Frank should stop at 3 drinks if he's going to be safe in how he's driving home. Now, there are also some other variables, and there's a longer version of this formula that takes more things into consideration, such as how long he waits before driving after he stops drinking, and just other factors like that that can come into play. But this gives some idea of how a person can set a limit to keep themselves at a safe level so that they won't have negative consequences from the party. Calculator!